everyone, welcome to our channel Knowledge of Friends. Subscribe to our channel and click the bell icon for the latest update. आज हम जो क्लास करने वाले हैं वो कंप्यूटर नेटवर्क की क्लास करेंगे, जो कि क्लास नंबर आपका 8 है। ऑलरेडी हमने 7 क्लासेस कर लिया है, जिसमें हमने यूनिट 1 कंप्लीट किया था, जो कि आपका यूनिट इंट्रोडक्शन कॉन्सेप्ट है। और यूनिट जो 2 है वो आपका जो हमने डिस्कस किया दैट इज़ मीडियम एक्सेस कंट्रोल सब लेयर, तो वो हम ऑलरेडी डिस्कस कर चुके हैं। अब जो हम स्टार्ट कर चुके हैं ऑलरेडी लास्ट क्लास से, वो हम यूनिट 3 स्टार्ट कर चुके हैं, जो कि नेटवर्क लेयर है। एंड नेटवर्क लेयर मोस्ट ऑफ द थिंग्स वी हैड कवर अप हियर, एंड होपफुली अगर आज का क्लास ज़्यादा एक्सीड नहीं होता है, सो वी विल कवरिंग दिस यूनिट एज वेल इन द टुडेज क्लास एज वेल। लेट्स गो अहेड, लेट्स सी हाउ इट विल नॉट एक्सीड more than 1 hour. And first of all, it's a huge request from my side to all the viewers, please go through with the subscribe button and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. And thanks to all the subscribers, those who had subscribed to our channel, because your support is important to us. Let's go ahead with the first heading, that what today we will discuss is about leaky bucket algorithm. Leaky bucket algorithm. In the leaky bucket algorithm, if I'm talking about, which has been very important because this has been asked of 10 marks, that is your leaky bucket algorithm here. And in the same case, if I'm talking about the leaky bucket algorithm, you have to know very few things that is very important in the leaky bucket algorithm. That leaky bucket algorithm, or leaky bucket, that is a bucket with a small hole in the bottom of bottom, and is used to store the water, and the outflow from the hole is at constant rate, and irrespective of the rate of entering the water. Once the bucket is full, any additional water entering it spills over the side and is lost. The same idea that can be applied to a bucket. This is similar to the single server queuing system with a constant service time as well. As we have told about it, that each host is connected to network with a finite internal queue, and the host is allowed to put one packet per second on the network. And if the packet arrives at the queue when it is full, the packet is discarded. The same reference that the mechanism turned an unregulated traffic of the host, that regulated traffic on the network, and thus the bursty traffic is smoothened and chances of congestion is reduced. And now we will show this by drawing a diagram, that is of leaky bucket regulator. This is here it is these packets towards it. This is unregulated packet flow. These were known as, okay, and this whole that what we had done is your leaky bucket. That leaky bucket, or you can say that host computer, with this that we have this is regulated flow, and this is output to network, or we can say that it is fixed rate. This is all we can say as leaky bucket regulator. In the leaky bucket algorithm, this has been used, and a leaky bucket regulator allows to control the average rate and the largest burst from a source. And a leaky bucket regulator has both a packet bucket and a data buffer, and the packet that arrives to the regulator that cannot be sent immediately are delayed in the data buffer. And the main drawback of the leaky bucket algorithm is that its output pattern cannot be modified, and that is, if the bursty traffic arrives, the output that should be speed up, and so that no packets will be lost here. With this, for the another that I will show about the leaky bucket algorithm that can be used in the police, to police the traffic flow. And for that, we will be here going to draw a flow chart, and for the policing as well. So let's go ahead here. So it will be shown like that only, you have to draw it. So with this, we have a flow here, and that is it will go toward this connect towards this, and this will go and towards connect this as well. So here with the naming, if I'm going to connect it, here it will be, and that is connected towards it. Okay, so I will be naming it out each and every box here, that what we have to even though discussed. That is here it is, that is arrival of a packet at time t of a, and where this is x dash equals to x minus t of a minus LCT, and here it will goes towards it, and this is your y where x dash is less than 0, and that is yes. If it is yes, then it will go x dash equals to 0, and if it is no, then x dash is greater than L here. And for that, this is your non-conforming packet, and here it will be x equals to x dash plus 1 plus I, we can say that, and this is for LCT, that is equals to T of A, that is conforming packet, and obviously we can say that in the same reference towards it. X equals to an x dash and as well as LCT. So here for the x, that is your value of leaky bucket counter. X dash, we have auxiliary value, and for for the LCT we have is your last conformance time. So these were the values, and that is denoted here, that is your leaky bucket algorithm for policing. So here this is, and at that arrival of the first packet, that the content of bucket X is set to 0 and the last conforming time is set to the arrival time of the first packet. And of course the depth of the packet bucket is L plus 1, where L typically depends on the traffic busness. Okay, so now here we'll go ahead and we'll discuss moreover related to this topic in the same references that we will be discussing about what is congestions, and name the technique that prevent congestion, and discuss any two technique in brief as well. In the same case, or they had asked you about 10 marks, and the same question, the another question they can ask you in this form, that is what is congestion and name the technique that is used here. And what you can say is as to be follows, like what is congestions and name the technique that prevent the congestions. So in this cases this has also been asked of 10 marks, so you can write it down in the congestions. So where the congestion stands for like that, when too many packets rushing to the node or the part of a network, the network performance degrades, and this situation is called as congestion. And when the number of the packet dumped into the subnet and as traffic increases, the network is no longer able to cope, and design losing packet at very high traffic performances collapse and completely almost no packets are delivered. So with this regard of it, we'll discuss one of the graph here. This is packet sent, this is your packet delivered. And where it the graph starts from here, it will goes towards it at a constant speed, and then of course then it will mold it out, and with this is goes down as well. So this is the congested, this is desirable, and this is perfect. Okay, so this the maximum carrying capacity of a subnet is here as well. And with this regard of it, that the congestions preventions, if I'm talking about where the precautions are taken so that the congestion cannot occur, and the congestion prevention tries to design policies carefully to minimize the congestion in the first place. And the congestion prevention policies that we have in reference towards the transport layer, network layer, and data link layer, that we will discuss here in a deep. So we will discuss about serial number, then we have a transport layer, then we have a network layer, and then of course we have a data link layer. Okay, so in the reference towards it here, that if I'm talking about so in the same references, the first we will discuss about the transport layer, that is the retransmission policy, and for the network layer, that is a virtual circuit versus datagram, and the data link layer retransmission policies as well. For the second, we have the congestion prevention policies. For the transport layer, we have an out of order catching policy, network layer में packet queuing and service policy, and the data link layer में out of order catching policy as well. The third we have, that is the acknowledgement policy for the packet discard policy, and for that data link layer, that is your acknowledgement policy. The next, for the transport layer, flow control policy. For the network layer, that is routing algorithm, and for of course the data link layer here, and that comes under it, and that what we had even though discussed about it. So in that same case, that the flow control policy. The fifth is that the time out determinations, packet lifetime management, and here it is not existing. So these were the things that what we have to consider about it. Let's go ahead with another one, and that what we have to discuss about the limitations of a leaky bucket algorithm. Limitations of leaky bucket algorithm. So in the leaky bucket algorithm, and how are they resolved, that what we have to discuss, that has been asked of 10 marks. And what are the limitations of leaky bucket algorithm and how these are overcomes, that also we'll have to discuss about it. And in the same case, the limitation of the leaky bucket algorithm, the first is that the main drawback of the leaky bucket algorithm is that its output pattern cannot be modified. That is, if the bursty traffic arrives, the output that should speed up so that no packets will be lost. The second is leaky bucket discards the packet, where the token bucket algorithm eliminates the drawback of the leaky bucket algorithm. And in this, the leaky bucket holds token, and these tokens are generated by the clock at the rate of the one token for every change in time second, and the token bucket burst of up to n packets, and that can send at once, and which gives a faster response to the sudden burst of input as well. The regulator collects a token in the bucket, and which fills up at steady drip rate by the packet, and when a packet arrives at the regulator sends a packet. If the bucket has enough tokens, then otherwise the packet waits either until the bucket has enough tokens, and if the bucket is already full of tokens, then incoming tokens overflow and are not available to the future packet as well. Thus, at any time, the largest burst a source that can send into the network is roughly proportional to the size of the leaky packet as well. In the same case, the regulator delays a packet if it does not have sufficient number of the tokens for the transmission, and a counter keeps track of token, and the counter is incremented by one every change in temperature, and decremented by 1 whenever a packet is sent. So when the counter hits 0, no packets may be sent, and smoother traffic can be obtained by putting a leaky bucket after the token bucket here. For the token bucket regulator, that what we had discussed in this class only, that the bucket holds the token periodically, and the token bucket is there, and the regulated flow has been gone through with that, the output to the network that is in the fixed rate here. So for that token bucket capacity we have C, and the token arrival time we will be having up bytes per second. So the maximum output rate is M, denoted by byte per second. So the maximum burst time for this maximum burst rate equals to, that has been denoted by S, which is S equals to C upon M minus. So this will be the formula when you have to find out the maximum burst rate here. So in the same case, now we'll discuss about write a brief note on the traffic shaping, and that has been asked of the 10 marks as well. So traffic shaping, we'll discuss about traffic shaping. In the traffic shaping here, that the traffic shaping is about regulating the average rate of the transmission, and the traffic shaping smooth out the traffic on the server rather than on the client side. Traffic shaping is an open loop method for the congestion control. So two types of algorithm are used for the traffic shaping. The first algorithm we have is that is leaky bucket algorithm, that we had even discussed in a detail in this class only. And the second we have token bucket algorithm. Token bucket algorithm, we had discussed about it, this one as well. Let's go ahead with another one, that is write a short note on a choke packet. In the same case of the choke packet here, that another mechanism for the congestion control is by using the choke packet, and the choke packet will have the effect of stopping or slowing down the rate of the transmission from the source, and hence they limit the total number of the packets in the network. and this approach requires the additional traffic on the network during a period of the congestion, and this can be applicable to both a virtual circuit and the datagram subnet. When a line utilizes increases and above some specific value that called a threshold, the line enters an alarming situation, and each newly arriving packet is checked to see if its output line is in alarming state or not, and if so, the router sends the said choke and packet back to the source, and this choke packet contains the destination address so that the source will not generate any more packets along the path. The traffic is reduced by adjusting parameters, window size, or a leaky bucket output rate, and typically the first choke packet causes the data rate to 50% of its previous value, and that the choke packet reduces the traffic 25%, and so on. The congestion control using the choke packet that can be done by the two ways. In the first type, that the choke packet affects only the source, and the second type, that the choke packet affects each hop it passes through, and that shows that the choke packet that affect only the source here. In the same case, a choke packet that affect each hops it passes through, like when we'll go ahead, like a subnet with a 6 node will be denoting here A, B, this is denoted by B, then C, D, E, F. So this is B, C, D, E, and F. They are connected to one another, and from A move towards E, and E to F, F to. So here the subnet with the 6 nodes A, B, C, D, E, F is shown, like as you can see here, and that the source node from A at destination node is D, so it will move like that. Okay, from one to another and another. इससे long हो जाएगा, इसलिए इधर से move किया. And when the link utilization increase above its threshold, a destination node D starts sending choke packets towards the source node A here. So for that, here that we can gone through with that. Here only it will move like that. If it will send from D to E, then it will choke. Okay, and in the same case that the choke packet travels through the shortest or the same path as that of the packet here, so the shortest path that it will covers here. Now we'll go ahead with the another one that what we have to discuss as well, and that is in the reference towards it. In the same case, that the choke packet reaches here, if it is choked, then of course if it will come here, then of course it will be choke here as well, and that the choke packet reaches to the source node, so of course where it is checked choke here, and that is comes towards it, so it will also choke here as well. So after receiving the first choke packet, a source node from A reduce its flows towards the destination here, and then of course that is here when it is choked, so this will be reduced flow, and that the reduced flow same for the reverse path, and that the path of the choke packets through the various nodes, and after that this reduced flow, then of course it is will be the reduced flow as well. And for that same case, that flow is the still maximum in here, but these were reduced, so the reduced flow reaches to the destination D, and then of course here also after that that is flow is reduced. When these were flow reduced, but this is not, so their flow is still maximum, but after coming towards it, then the choke take place, so flow is reduced here as well. In the same case, a choke packet that affects only the source here, as you can see here, and with this choke packet that affects each hop it passes through, and with this regard of it, after that we will be going ahead here, that is for the another one, A, B. This has been named here. With this is A, B, C, D, E, F. Okay, so when for the same subnet having a B, C, D, E, F source node with the destination A, so it will be like it will be moving like here to here, and it's from here to here. So here it will be the heavy flow. Okay, When a link utilization increases above its threshold, destination node D then starts sending choke packets towards the source node A here. Then it will choke here. And that the clock choke packets follow the exactly reverse path of traffic flowing packet, and here the choke packet reaches to the node F, and immediately after reaching the choke packet at node F, the traffic flow towards the node D reduces here. So when it comes here, then there is a heavy flow, and after that it will reduce flow here. And so here with this reduced it will reduced flow here, and after the heavy flow as well, and after this it will choke here. And with this that the node D will be reduced here. And after that we are going to discuss about it for the choke point, and that the choke packet crosses node A, and then of course that the traffic flow between the nodes that is E and F and D is reduced, and when it comes towards it, choke takes place here as well. And then other than that, after reaching the choke packet to the source node A, that the traffic flow between the node A and node E, hence up to the destination node D, is reduced, and that will be reduced here. That flow is reduced after this, it will reduced here, and after that it will reduce as well as here also. Okay, so with this concept, now this is a choke packet that affects each hopes it passes. जैसे ही वो पास करेगा वैसे ही उसे रिड्यूस स्लो कर देगा. ऐसे क्या हो रहा था, जब वो आगे तक पास हो रहा था, देन लास्ट को वो चोक कर रहा था जब तक वो अपने सोर्स कोड पे नहीं पहुंच रहा था. बट यहाँ हॉप बाय हॉप हो रहा है. सो हॉप बाय हॉप choke packets here that over a long distance or at a high speed, the choke packets are not very effective, and a more efficient way is to send the choke packets hop by hop, and a congested node that would again generate a choke packet, but each hop would be needed to reduce the transmission even before the choke packet arrives at the source here. Now we'll discuss about the networking here. In the internet networking, they can ask you about what is meant by the fragmentation. So that we'll discuss here. Fragmentation. In the case of the fragmentation here, that what is meant by the fragmentation is the fragmentation needed is concentrated virtual circuit internet or in a datagram circuit system. That has been asked of the 10 marks here. So we'll discuss that fragmentation in the detail here as well. In the fragmentation means that the division of the packets into the smaller units to accommodate a protocol MTU, and each network imposes the some maximum size on its packet, and these limit have various causes among them, and hardware, that is US protocol, etc. as well. And that for the fragmentation, that means basically to divide, and for that we will be having a sort of a diagram as well. This is packet, then after that we will be having a G1, which is breakdown. It's to G2. This is network 1. Then after that, this is G2, that is the resemblance, the fragments, and their G1 fragments large packet, it will goes towards it. This is G3 to G4. It will go towards the G4, that is your resemblance again as well, and the G3 fragments again here. So this is what we can say, that is a fragmentation here. The fragmentation, the maximum packet size may vary from one network to another, and either of the fragmentation and the assembly function that can be performed on a per network basis as well. Fragmentation is needed in the concentrated virtual circuit and a datagram system. Even in the concentrated virtual circuits network, some network along the path might accept 1024 byte packet, and the other might only accept 48 bytes packet. The fragmentation is still needed. The internet is a datagram network. This means that the network layer only provides the datagram services in the case of the internet best effort. The network layer does not provide reliability or connection services to the transport layer as well. And when an IP datagram travels from one host to another, it may pass through the different physical network, and each physical network has a maximum frame size called maximum transmission unit, which stands for MTU, and which limits the datagram length. And a fragment is treated as a normal IP datagram while being transported to their destination, and thus the fragmentation of the datagram each have a header. If one of the fragments get lost, the complete datagram is considered lost here. In the same case, it is possible that the fragments on the same IP datagram that reach the destination host via the multiple routers, and finally, since they may pass through the networks with a smaller MTU, that is your maximum transmission unit, and that then the senders one, so they are the subject to further fragmentation as well. In the same case, the another thing that can ask is what do you understand of the internet working, and discuss the parameters on which the network differs, and with this the functions as well as that what we have to discuss about it, and for the significance of internet working also we have to discuss about it. So we'll start with internet working. So in the internet working here, that is also a long topic that what we have to discuss about it, and in the same case where we have to gone through with that as well. So in the internet working here, that in a LAN, when a number of users or the stations are more, and if the station are located at a longer distances, forming bigger LAN is not always possible due to the following limitation. The first is that the constants of the maximum number of stations which can be connected on a single LAN, and the second is that the constants of the maximum physical size of a LAN as well. The third is that the network security, and the fourth is that the investment already done by the further to be done here. If the LANs which are geographically separated, or if they are located in a different that the corners of the city or in a different cities that are needed to be connected or communicated, again these LANs that may not be of the same type, and that is one of these maybe CSMA series LAN, and the other may be FDDI LAN as well, the different LANs that can be interconnected. The LANs and the switched data subnets that are interconnected to allow the users to communicate across several subnets, and this extended network so formed is called internetwork as well. The subnetworks interconnected may differ in the technologies, topologies, protocol, and their services as well. Therefore, some spatial intermediary devices that are required to sort out the differences, and that enabling the users of one subnet to communicate with the user of the another subnet as well. And the internet network device such as the bridges, router that are used to connect the two or more LANs or subnet as well. We'll discuss about the functions of intermediary devices here. In this, that the matching the protocol of the peer layer. The second is that the matching the services offered by the different layer, and the third is to relaying that is the data units from the one subnet to the another, and the fourth we have that is the routing of the data units from one subnet to the another. So here each intermediary devices has a different capabilities and a function as well. With the same case talking about it, now we'll discuss about the significance of internet networking. Significance of internet networking. So here with this significance, the first is that it provides a link between a network. The second is to provide routing and delivery of the data between the process on a different network here. And the third we have here in the same references that provides an accounting services that keeps the track of the various network and the router, and that maintain the status information. And the fourth we have here is your internet working facilities that accommodate a number of the differences among the network, which includes a different addressing scheme, different maximum packet size, different access mechanism, and error recovery status reporting technique, etc. So here in the same references here. Now we'll discuss about the collection of interconnected network here. So for that we have a diagram, and that is okay. We'll sort of we'll do it here. This is SNA network. This is mainframe. This is ATM network, which where both were connected to the FDDI ring, and this is connected to 802.11. This is a wireless, and where it is also connected to and this router, this is router that is to connect it to the internet. Okay, so here with this regard of it, if you had not gone through with that, you can see it. Okay, so here in this is the interconnected networks here, where the Ethernet is this, and this is a router that is connected to the internet, and that a corporate network with a multiple location that tied together with a wide wide area, that ATM network, and all the different networks are connected together with the FDDI ring. And the main purpose of the internet networking network is to allow the users on any of them to communicate with the user on all the other ones, and also to allow the users on any of them to access the data and any of them here. Now how network differs, that what we have to discuss here. How networks differ. So in the how networks differs here, the networks are differ in the physical and a data link layer by the modulations technique and a frame format, and the difference in the network by this parameter in the network layer is as to be follow: the serial number, the parameters, and the sum possibilities, that what we'll discuss about it. The serial number, then we have parameters, and of course then we have some possibilities. So here we'll discuss about the parameters as well. The first serial number we will be having is your, that is your service over offered. In the service offered here, that the connect in the some possibilities, that the some connection oriented versus connectionless here. So the second we have here is, that is your protocols. In the protocols here, that is some possibilities is your IPX and SNA, and then of course the ATM and MPLS, etc. Now we'll discuss about the third one, that what we have is your, that is addressing. In the addressing here, that is the first versus hierarchical, flat versus hierarchical, that is your the some possibilities, flat versus hierarchical. The fourth we have is your multicasting. In the multicasting here, that is present or absent. The fifth we have is your packet size. In the packet size, every network has its own maximum. The sixth is your, that is the quality of services. Quality of services has been denoted by QoS as well, and that is your present and absent as well. Present or absent. The seventh we have here is your error handling. In the error handling, that is your reliable, ordered, unordered delivery. The eighth we have here is your, that is your flow control. In that flow control, that is your sliding window rate control. Ninth we have is your congestions control. In the congestion control, we have a leaky bucket, and that is your red and then token bucket, choke packets, etc., that has come under the congestion control, even though that we had discussed about it as well. The 10th we have is your security. In the security, that is encryption. Then the another one we have for the 11th one, that is your parameters. In the parameters here, it is your different timeouts, flow specification, etc. And the 12th and the last we have is that is your accounting. In the accounting, that is by the connect time, by packet, by byte as well. So this is what we have to discuss, how network, that they have, and that we have discussed about it as well by one, and these were the 12 as well, that what we have to discuss here. So now we'll go ahead with the another one, that what we have to discuss is that if the fragmentation needed in the concentrated virtual circuit network or any of the datagram system, that has been asked many times in the examination paper, and that is of 10 marks one time, and then there's another time that they had asked about the 15 marks as well, so which is very important. Now we'll discuss about the logical addressing, that is IPv4 address. Logical addressing, that is known as IPv4 addresses. So in the logical addressing IPv4 addresses here, now we'll discuss a question with related to that. So here the question we have, that is perform the subnetting of the following IP address 160.11.x.x here, and that is original subnet mask that is 255.55, 255.0.0, and number of subnet is 6. So this has been asked of 10 marks, which is very important in the reference towards it. I will go ahead with the solution here. So here with this we'll go ahead with the solution, that the given IP address of the class B address, that is 16-bit, is used for the subnetting, and here that is number of subnet equals to 2 to the power n, and where 2 to the power n, that is 2 to the power 3, and which is equals to 8 here. So we want 6 subnet for but using 3-bit we get 8 subnet. So the subnet mask will be, that has been represented 255.255.111.0.0.0 and then 0.0. So this is that has been represented, so we can go ahead like 25.5, 255 and 0.224.0. so the number of subnet here that we have for the first subnet, that is 160.11.0.0. for the second subnet 160.11.32.0. third subnet 160.11.64.0. fourth subnet that is your 160.11.96.0. the fifth subnet 160.11.128.0. the sixth subnet that is 160.11.160.0. The seventh subnet, that is 160.11.192.0. The eighth subnet, that is 160.11.224.0. So here, that is the solution. You can just copy it out, and if you're making notes, that is good for you as well. Let's go ahead with another one, that what we have to discuss, that is given IP address, how will you extract at net ID and host ID and compare the IPv6 and IPv4, that is with the frame format as well. So first we'll discuss about given IP addresses, how will you extract the net ID and a host ID, and then after that we'll discuss about the compare IPv4 and IPv6, that has been asked of 10 marks as well. So let's go ahead here. Here we'll discuss about it IP address, which comes under ID, net ID and host ID. So here in the same case, that the addresses structure was originally defined to have a low two hierarchy, that is network ID and a host ID. In the network ID and host ID, the network ID identifies the network to the host is connected to, and the host ID identifies the network connection to the host rather than the actual host. In a class A network, the first byte is assigned to a network addresses and remaining the 3 byte used to the node addresses, and the class A format is network.node.node.node here. In the class B network, the first 2 bytes are assigned to the network address and remaining 2 bytes are used for the node addresses, and the format is network.network.node.node. In the class C network, the first 3 bytes are assigned to the network addresses and only 1 byte is used for node addresses, and the format is network.network.network.node here. This is a reference towards classes. The class A having a network.node.node.node, and for the class B, that is network.network.node.node, and for the class C we have network.network.network.node. So this is reference towards the classes. Now we'll discuss the comparison between IPv4 and IPv6. So here in the sequence, that what we have to discuss IPv4 and IPv6, which is very important here as well. In the IPv4, that it is the header size is 32 bits, okay, and for IPv6 here, that the header size is 128 bits. The second comparison, it cannot support that auto configuration, and here this that supports auto configuration. The third difference is that cannot support real-time application, and even though that supports the real-time application here as well. So here we'll compare the between IPv4 and IPv6 here. That is, as we had discussed about it, that is the port configuration that cannot support real time. Here it cannot support real time application, and it support the real time application as well. This is the third difference. The fourth difference we have is that no security at network layer, and for the IPv6 provides security in a network layer. And the fifth differences we have, that is a comparison we have, that the throughput and the delay is more, and here that is the throughput and the delay is less here. In the same case, if I'm talking about with the IPv6 and IPv4 header format, and that is we will do it, and for that it will consist of the process, that the format and the reference towards the format they had told you about it. So that is necessary to draw that diagram. So we'll go ahead. First we'll go ahead with IPv4 frame format. So for the IPv4 preframe format here, the first we have so here it is, and then that is your 0, this is 3 4 that has been put down, which is your 7 and 8, then we have 15 and 16, 18 and 19, and of course this is 31 as well. So here this has been gone towards the line here as well, and then we have here from 15 to 16 that it will be like this, and this is from 18 to 19, and that is we had drawn here, but this is not mandatory here, sorry. Here it is, and then other than that we have drawback line here as well, and then after that other than that here as well, that is comes under towards its 7.7 to 8 here, then it will be like this only. Yes, and then after that we have no lines putting in out. This is IPv4 frame format, and where we'll write it down, this is your, that is your, that is a where, that is a 4-bit, then HEL, that is of 4-bit, then this is your, that is your service type, this is 8 bits, and this is total length is of 18 bits, sorry 16 bits. This is your, that is datagram identification, that is of 60 bits. This is flags, 3 bits. This is fragment offset, 13 bits. This is your time to live, 8 bits. Protocol, 8 bits, and this is header checksum, that is 16 bits. Source IP address, that is 32 bits. Then we have here is your, that is your destination IP address, that is 32 bits, and then of course this is options. So here this is IPv4 header format. Now we'll draw a frame format that is for IPv6. Frame format. So here for the IPv6 frame format, that what we have to discuss here in the same reference towards it, that is In the same case here, that is your 4 bits, 4 bits, 8 bits, 8 bits, 8 bits. Okay, so here this is your then here it is your next header and a header length. Then here also the next header and the header length. And then another one that is your blank. Then again we have the next header and the header head. Okay, this is IPv6 headers here. In the same reference towards it, that is your, this is PRI, and this is flow label. This is your payload length, next header, and this is hop limit, and this is your source address, destination address, then we have here is your next header, here it is, that is your next header, header length, next header, header length. This is IPv6 headers here as well, and as of now that we will discuss moreover regarding to that, and that is your how is subnet mask useful in IP addressing, and explain with an example that we have to discuss here. So in that same references will go ahead, that is your subnet mask useful in IP addressing. Here in the same case, which is that if an organization is large, or if its computer are geographical dispersed, it makes good sense to divide the network into smaller ones and that connected together by the routers. And the benefit of doing things this may include, the first is that is reduced network traffic, the second is that optimize the network performances, and that is the third we have is just simplified network management, and the fourth is that the facilities are spanning large geographical distances as well. In the same case, if the network information center, that NIC we have told about it, this has been asked of 10 marks here as well, that assigns only one network addresses to an organization which having a multiple network, that organization has a problem, and a single network address that can be used to refer to the multiple physical network, and an organization that can request individual network address for each one of its physical network. If these were granted, they would not be enough to go around for everyone. The another problem is that if each router on the internet needed to know about each existing physical network, routing tables would be impossibly huge, and this is physical overhead on the router. And to solve this type of problem, the subnet addressing method is used here, that to allow a single network address to span multiple physical network is called subnet addressing or subnet routing or subnetting as well. The subnetting is required part of an IP addressing. To understand the subnet addressing, consider the next example, like considering that the site has a single class B IP network address that is assigned to it, but its organization has two or more physical network. Only local routers know that there are multiple physical networks and how the route traffic among them. And the example that the organization is using the single B a class B network, so address for the two network as well. The subnet address scheme to work, every machine on the network must know which part of the host address will be used as subnet address, and this is accomplished by assigning each machine a subnet mask. The network administrator creates a 32-bit subnet mask that is comprised of ones or zeros, and the one of the subnet mask that represent the position that refer to the network or the subnet address. The zeros represent the position and that refers to the host part of the address as well. The class B address, if I'm talking about here for the class B, that in the reference towards a class B network, that is the format is net.net that is your network.network.node.node here. And for this here in the same references, that is in the same cases, that we can say that the third byte normally that assigns as a part of the host address and is now used to represent the subnet address, and hence these bits are positions that are represented with another ones of the subnet mask. And that the fourth byte is also only is an example of that represent the unique host address as well. For that, if I'm talking about the internet has been gone to the routers, and the router all the traffic that what it has, it will be connected to all the multiple networks here. that is जो मल्टी नेटवर्क या मल्टीपल नेटवर्क हैज़ बीन यूज लाइक जैसे कि आपके घर में वाईफाई कनेक्शन होता है तो आप सीधे इंटरनेट आपका राउटर पे आता है, एंड द राउटर से आप जितने भी डिवाइसेस चाहो उतने डिवाइसेस आप कनेक्ट कर सकते हो. That is for the reference towards a multiple network, but they have an IP addresses, different IP addresses here as well. The subnet mask code, if I'm talking about the subnet mask code, so that is 2, that is 1 and 0, and for the 1 here, that is the positions representing the network or a subnet addresses, and for the 0 here, that the positions representing the host address. Now we'll discuss about it, that is the subnet mask format. In the subnet mask format here, that is we have that is presented here 1 1 1 the 1 1 1 1 1 1 1 1 1 1 1 1 1, and then again 1 1 1 1 1 1 1 1 and 0 0 0 0 0 0 0 0. So these were the network address positions. Network address position, and this for the subnet, that is your subnet position, and this is host position. Okay, so the subnet mask that can also be denoted using the decimal equivalent of the binary pattern, and that the default subnet mask of the different classes of network that are used here. For that we have a classes, and then we have a format, and yes, default subnet mask as well, and that will be discussed here in the same case, and that is represented here as well. This is class, then here we have class here, and that is your format, and this is default subnet. In the same case, if I'm talking about here, that is in the reference toward the class, so this is a class that where we have net.node.node, and this is for that default subnet mask we have here 255.000. and for the class B here, that is your net.net.node.node, and for that default subnet marks we have 255.255.0.0. Then for the class 3 we have here, that is your net.net.net.node, and for that default subnet mask we have 255.255.255.0. So this is what we have to discuss here, and in the same references, let's go ahead with the another, that is the default subnet mask of an IP address here. So here we'll end up with this class. We'll discuss some of the short answers, that is what is the address resolution. In the address resolution, if I'm talking about that, the address resolution is the process of obtaining the physical address of the computer that is based on its IP addresses, and in order to be able to finally actually translate the frame or a datagram over the network to which the node belongs. The second they can ask you is what is the purposes of address resolution protocol, that is ARP. In the same references, the ARP is a dynamic mapping method that finds a physical address for a given logical address, that is your mapping IP address to the physical address as well. In the same case, what is the benefit of DHCP? In the DHCP benefit, the first is the simplicity, that is the client need no manual configuration. The second is the mobility of the host, that is your host may move between networks without reconfiguration. And the third is the mobility of the network, that is the possible for the internet service provider that reconfigure customers address transparency, that is node. And how about renumbering the kills existing the TCP connections as well. The fourth is that the safe address space if individual clients are not always active. The another thing that they can ask you about, what is an IP addressing? And an IP address is a numerical label assigned to each device in a computer network that uses the internet protocol for communication. The two important functions at IP addresses, the first we have the host identification, and the second is your location addressing as well. Talking about the next, that is your what is the routing here. In the same case, the routing is the process of selecting the paths in the network through which the network traffic is sent as well. These were the things which is very important. Now we'll discuss discuss the principles of reliable flooding and its advantages and application as well. With the same concept, that the principles we have, that making sure that all the nodes participating in the routing protocol that got a copy of the list state information from the other nodes as well. The second is that the periodically sent link state packet, that is LSPs, on the links as well. Use explicit acknowledgement for the retransmit to make the flooding reliable. The fourth is each LSP will travel at most once over each link as well. With the same concept, with the advantages, if I'm talking about, with the first advantages, it is shortest path algorithm. The second is there is the guarantee of the delivery of the packets, and the third is that is simple to implement as well. The application is that is used in the military application used to link the state routing algorithm as well. The same is that another, what are the silent features of IPv6? The silent features of IPv6 we have that the efficient hierarchy addressing and routing infrastructure. IPv6 network provide auto configuration capabilities, improved security features, better support for the QoS, large address space, and the stateless and the stateful address configuration as well. Talking about the another one we have is that is defined BGP, that is the border gateway protocol, as a standardized exterior gateway protocol that is designed routing and reachability information between the autonomous systems on the internet. And what were the metrics method that is used for the routing protocol? That is the traffic matrix, distance matrix, adjacency matrix, service matrix, performance matrix as well. That is what we have discussed about it, and that is we'll go ahead with the detail as well, and we'll do sort of a questions as well that is related on network layer basis on the behalf of it, and we will discuss the detail of the IPv6 as well, and they can ask you about the broadcast IP addresses, and of course the counter infinity problem, the routing here, that is the duties of the routers, that all are comes under in it, and you have to go through with that as well. So class आज के लिए इतना ही. Thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box, and please like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. In this that we had discussed about unit 1, that is your introduction concept, and that is your goals and applications of network structures and architecture, the OSI reference model, service and network topology design, delay analysis, backbone design, local access network design, physical layer transmission media, switching method, ISDN terminals handling as well. In the Unit 2, medium access sublayer, that is medium access sublayer, channel allocations, LAN protocol, Aloha protocol, overview of IEEE standards, FDDI data link layer, elementary data link protocol, sliding window protocol, error handling. In the Unit 3rd, we had cover up network layer, point-to-point the networks, routing, congestions control, internetworking, TCP, IP packets, IP address and IPv6 जो कि हमें करना है and hopefully next class में हम आप Unit 3rd complete कर भी लेंगे. Unit 4 जो कि हमें ट्रांसपोर्ट लेयर करना है, ट्रांसपोर्ट लेयर, डिज़ाइन इश्यूज़, कनेक्शन मैनेजमेंट, सेशंस लेयर, डिज़ाइन इश्यूज़, रिमोट प्रोसीजर कॉल, presentation layer, design issues, data compression technique, cryptography, TCP window management as well. The Unit 5th, that is your application layer, application, file transfer, access and management, electronic mail, virtual terminals, other application examples, network, internet and a public network. That what we have to cover up in the next coming class. So first of all, it's a huge request from my side to all the viewers, please go through with the subscribe button and please like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Thank you. Thanks for supporting us. Thanks for subscribing us.